Hello. So we are doing geometry, chapter 2.6, proving geometric relationships. Okay, so we'll do some theorems and also we'll try another proof format, which is a flowchart proof or flow proof, where we use boxes and arrows like this, and we uh, we use arrows to show the flow of logical arguments. So first let's do theorems. So right angle congruence theorem says all right angles are congruent. Like if this is angle A and this is angle B and both are right angles, so they are congruent. Now let's learn congruent supplements theorem. So congruent supplements theorem says if two angles are supplementary to the same angle or to congruent angle, then they are congruent. So suppose if this is angle 1 and this is angle 2, okay. So angle 1 and 2, they are supplementary, and there is another angle, angle 3. So 2 and 3 are supplementary. Then angle 1 must be congruent to angle 3. Basically, angle 1 plus 2, if they are supplementary, it is 180. 2 plus 3, if they are supplementary, it is 180. Then, if angle and angle 2 is same, so angle 1 is congruent to angle 3. So they can be supplementary to same angle or to congruent. Let's do another theorem. So congruent complement theorem says that if two angles are complementary to same angles or congruent angles, then they are congruent. Like suppose this is angle 4 and this is angle 5. Okay. So 4 and 5 are complementary and 5 and 6 are complementary. Then angle 4 and 6 would be congruent. So 4 and 5 are complementary, 5 and 6 are complementary, then 4 and 6 would be congruent. Let's do another theorem. So, linear postulate pair postulate says that if two angles form a linear pair, then they are supplementary. So, linear pair is basically a set of two adjacent angles whose non-common sides form a straight line or a straight angle. So, this is a linear pair. Okay, where two non-common sides form a straight line, or we could say so. These angles 1 and 2, they are supplementary because they form a linear pair. The two non-adjacent sides form a straight line. Okay. Now let's do another theorem. So vertical angle congruence theorem says that vertical angles are congruent. So vertical angles are a pair of opposite non-adjacent angles formed when two straight lines intersect at a single point like this. So these angle 1, 2, 3, 4. So angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Okay. So these are the vertical angle congruence, vertical angles, and vertical angles are congruent. They are formed when a pair of opposite, they are pairs of opposite non-adjacent angles when two straight lines they intersect at a single point. So now let's do some problems and then it will be more clear. So this is a diagram given to us and we have to identify the pair of congruent angles. So one is given is MSN and PSQ, both have 50-degree. So the second one is like we can see angle MSP and angle PSR. They both are congruent because they form a linear pair, means they are supplementary by linear pair postulate. And if one is 90-degree, the another should be right 90-degree, and all right angles are congruent by right angle congruence theorem. So that's why these both angles are congruent. So MSP is equal to PSR. They form a linear pair, which means that they are supplementary by linear pair postulate. Now PSR is already given 90-degree right angle. So MSP will be also right angle because they are linear pair, means they are supplementary. So by subtraction property of equality, we do 180 minus 90 is 90-degree, which is MSP is right angle. And since both are right angles, so by right angle congruence theorem, we say that MSP is congruent to PSR. Now the another angle which is equal is NSP, this one, and NSP, which is, I'll show with another color. This is congruent to this. This is they are congruent by congruent complement theorem. So congruent complement theorem, here we can see that this is NSP and this is congruent to angle QSR, this. Okay. So both of these angles are congruent because of the congruent complement theorem, because they are complementary to congruent angles. We saw that MSN was congruent to PQS. Okay. This MS MSN was 50-degree and this is 50-degree. So NSP is congruent to MSN, which is they are complementary to congruent angles. So that means that they are equal. They are congruent. So in this case, we see here that MSN and PSQ, they are given as 50-degree. So their measure is equal, means they are congruent. So angle MSN is congruent to angle PSQ. Now we see that MSN and NSP are complementary here. And we also see that PSQ here is complementary to QSR because it was given 90 degree. Uh, so they are complementary. Now, NSP, and we already know that MSN is congruent to PSQ. So NSP is congruent to QSR by congruent complement theorem because they are complementary to the congruent angles, which are MSN and PSQ. So let's do now question 4. Meanwhile, please read question 3. If you have any difficulty or doubt, just let me know. So we have to write the pair of congruent angle in the given figure. So in this, we can see that GML is congruent to HMJ because by vertical angle theorem, they are cutting the lines like this. And in GMH, this angle is congruent to LMJ, again by vertical angle theorem, like this. Okay. So we see that JMK is congruent to GMK because GMK and GMK, they both form a linear pair. So they are supplementary by linear pair postulate, GMK and this. They are supplementary by linear pair postulate, means they are equal to 180 degree. And because this is already given 90 degree, KMJ or JMK is already given 90 degrees. So by subtraction property of equality, we also get GMK as 90 degree here. And since both are 90 degree, means they both are right angle. And by right angle congruence theorem, we know that all right angles are congruent. So GMK is congruent to JMK. So this is question 12 of the book, and we have to find the values of x and y using the theorems we just learned. So let's do this. So we see that this angle 4x is equal to 6x minus 26 because they are vertical angles. So now we subtract negative 6x from both sides using subtraction property of equality. So we used subtraction property of equality and that gave us minus 2x is equal to minus 26. Then we use the division property of equality and we divided it by negative 2. So this gives us x is equal to 30. Now let's do one more problem. Let's find the value of y, sorry. So this was vertical angle congruence theorem we used for this. Now to get the value of y, we can use linear pair postulate also, as this angle and this angle both equal to 180 degree. They are supplementary. Or we can use the vertical angle theorem using this angle is equal to this angle. So this is linear pair postulate. So both of these angles, suppose this is angle 1 and 2, so they add up to 180 degree. If two angles form a linear pair, they are supplementary, and supplementary means that they equal to 180 degree. Now let's solve this equation. So now we see we substitute x is equal to 13 here, and we got 78 minus 26. We simplify here. So we get 65 plus 60 is equal to 180. Now subtracting 60 from both sides using subtraction property of equality, we get 6y over 120. Now we want to get rid of 6. So division property of equality, we divide by 6. And 120 by 6, we get y is equal to 20. So we get y is equal to 20 and x is equal to 30. Now let's do one more question. So this is question 17. Complete the flow chart. This is given in a flow chart form, which uses boxes and arrows. So arrows are shown there to show the flow of the logical argument. And each reason, here we write the reasoning below the statement that it justifies. So now we can complete this flow chart. So as we do, we write the reasoning below the statement in the flowchart. So this angle 1 is congruent to angle 3 is given. And this is angle 1 is equal to angle 2. This is because of the vertical angle congruence theorem. And so is angle 3 is equal to angle 4. Because of the vertical angle congruence theorem, which is given here. Then 1 is equal to 2 and 1 is equal to 2 and 1 is equal to 3. Okay, so 2 is equal to angle 3 by transitive property of angle congruence. And same way, angle So angle 2 is equal to 3, which is given here. 3 is equal to 4, which is given here. So by transitive property of angle congruence, angle 2 is equal to 4. Because angle 2 is congruent to angle 3. Angle 3 is congruent to angle 4. So angle 2 is congruent to angle 4. This is by transitive property of angle congruence. Okay. Now we have to write a two-column proof. This was a flow chart. Okay. So this is a two-column proof. So we see that angle 1 is equal to angle 3, congruent to angle 3, which is given. Then angle 1 is equal congruent to angle 2, and angle 3 is congruent to angle 4 by vertical angle congruence theorem. And then angle 2 is congruent to angle 3 by transitive property of angle congruence. And then angle 2 is congruent to angle 4 by transitive property of angle congruence. So this is a two-column proof and this is a flow chart. Let's do one more problem. So the reasoning, I'm just giving this again in case there is a confusion. So for this, angle 2 is congruent to 3. See, angle 2 is congruent to uh, so from here we see that angle 2 is congruent to angle 1 from here, and angle 1 is congruent to angle 3 is given. So by transitive property of angle congruence, angle 2 is congruent to angle 3. So in this given is that AEB is equal to DEC, which are given by the red marks here. And what we have to prove is AEC is equal to DEB. So let's use two column proof to prove this. So angle AEB is congruent to angle DEC, which is given. We can see the red markings there. So now if both of these angles are congruent, then measure of the angle AEB is equal to measure of angle DEC. This is by the definition of congruent angles. Congruent angles have same measure of degree. So we see that DEB, this is DEB angle is equal to BEC. So we see here in this DEB is equal to BEC, this angle, and CDEC. Okay, so we are using angle addition postulate here. So in this case, now we can, since it was given AEB is equal to DEC, so we'll substitute DEC with AEB. Okay. Using substitution property of equality. Now, same way we did for DEB, for AEC, we can write like this is AEC, and it can be written as using angle addition postulate, it can be written as sum of this angle BEC plus AEB using the angle addition postulate. So we see that AEC is equal to BEC plus AEB, and measure of BEC plus AEB is equal to DEB. So this is suppose 1, this is 2, this is 2, this is 3. So 1 is equal to 2 and 2 is equal to 3. It means 1 is equal to 3. So a measure of angle AEC is equal to measure of angle DEB using transitive property of equality. Now, since measures are equal of an angle, we can use the definition of congruent angles and see if the measures are equal, then angles are congruent. So when the measures are equal, then angles are congruent. Okay, so this is by the definition of congruent angles. So we have proved that AEC is equal to DEB, is congruent to DEB. angle AEC is congruent to DEB. So please let me know if you have any difficulty, and please continue practicing. Please do all the questions of the exercise. Thank you.